is going on, guys? We are back here with Jordan from Modular Head Shop.
Alright, hey everybody, Jordan with Modular Head Shop. Alright, so today we're actually not going to be assembling the heads, but we're going to be machining the heads. So I'm going to take you through everything as far as valve guide installation, valve guide sizing, regrinding the valves, and then valve seat machining and how all that works. So the first portion I'm going to show is trimming valve guides to fit the port shape. So I have a couple different GT500 ports. The roofs have different heights, and so we're going to trim the guide to fit this exact port. This is actually the guide that I use on my 03 Cobra heads on the intake side. But since the GT head has a much taller roof, we're going to shorten it up to complement the port design. Alright, so the number I need to take off is 296,000. So I'm going to index it here off the tool, set my DRO x-axis to 0. Now you can see I have a number here already. That number is going to go to 0, and that is for my inside diameter chamfer. Typically I would use a parting tool just to cut this off, but since I want to put a chamfer, I have this tool set up so I can do an ID chamfer and an OD chamfer after I trim the guide and not have to change any tools around. So now we're just going to verify the length. Like to be within a thou or two. I was shooting for 1/900, so that's pretty damn close. So I'm going to pick up this tool actually so you can see. Filthy thing. So the reason I indicated the 0 is when I want to do the ID chamfer, if you can see, there's not a ton of room. If you go too far in, then you're going to hit the shank of the tool on the guide before you actually get it chamfered. If you're too far out, then you're simply just going to peck the part that shouldn't be machined. So that's why I set that to 0. It's just a little reminder, hey, this is where you need to make your ID chamfer, and that's it. The outer ID I just eyeballed. Alright, so what I was trying to explain earlier was when I had the Z-axis set to 0, that was just to set my depth so I could put the correct chamfer on the ID of the guide. Because the ID of the guide is pretty small here and my cutter's not the smallest thing in the world, I have to have the depth correct, because if I'm too far inside, I'm going to have to go too far in and I'll shank out here against the back of the guide before I'm able to chamfer it. So that 0 is just a good indicator of where things are, because you can't necessarily see in there very good when the machine's running.
This tinsel came from Andrew's GT500, from a part that's going to be in the GT500. So if anybody wants this, first person to comment tinsel on the video gets it. I don't think anybody will want it, but
I mean, you never know.
Just in case, it's here.
Woo! That looks pretty. Oh yeah.
Alright, so last time we ported the head. We haven't touched it since, so now we're ready for valve guides. So what I'm going to do is just go over like my basic valve guide prep and then installation. And then once they're all installed, then we'll go over valve guide sizing. So these are not shouldered guides like a lot of push rods are. So, you know, push rod guides, if they have a shoulder, you just knock it in until it hits the shoulder. A lot of guys do that. So these would have to have a depth setter. So this is a tool, pretty common tool. I would say most machine shops have it. It's from Goodson. It's an adjustable depth setter, and it has different arbors that locate the guide. However, they're thin here on the outside, so they tend to ding the head a little bit, and they like to break too, so just like that. So what we do, since we use the same stuff almost all the time, is we will make our own. So this one's just welded, heat treated, and set to the depth that we want, and it's got a much wider base so it doesn't ding the head up. One thing I've seen a lot during valve guide installation is if the valve guide's tapered, it can sometimes have a sharp spot. These are not, these are radiused at the very end, which is nice, but just galling from maybe having a high spot from knocking the old guides out. So all I do is I simply just dress the guide bore, not looking to take out any material. I'm simply looking to just make sure there are no burrs sticking up so we don't gall the guide bore when we're installing the new guides. So very, very simple. Nice little shorty worn out diamond hone. I don't know if you can you get your camera down in there to kind of see the burrs hanging out where the port was? Can't really see it good, I don't think.
No, take our word for it.
Yeah, take our word for it. There's always going to be little burrs hanging out at the very, very bottom where the, where the port got cut off at the valve guide. So this eliminates that as well. Alright, so now all the valve guides are in, and we're going to show you how they look in the port. Now you can kind of understand exactly why I trim them the way I do. So, can you get a good shot of that, Andrew?
Oh yeah.
So we want the most valve stability possible without the valve guide hanging into the port a ton. So that's why we taper them. Now, I'm sure everybody that's looked at pictures of ported cylinder heads have seen the old, let's whack the valve guide off at the port. That is the dumbest thing I've ever seen. I would never, ever say to sacrifice valve stability for the simple fact of a couple CFM. That's how I like them, that's how I've always done them, and that's how we'll continue to do them. Alright, so now we have the guides in. I'm going to go over valve guide sizing. This is the tool I use for valve guide sizing. It's made by a company called Goodson. Uses a diamond stone. I feel like it's the best, really just the best way to do it. There are reamers that people use. You can get a solid carbide reamer for about $220, but it is specific to a size, non-adjustable, and after 200 of these valve guides, you're throwing it in the trash. So this diamond, we probably get 1,000 valve guide sizes out of one replacement diamond, and it just pops in and out. And they're available for different sizes too. So we size everything just like this. There are valve guide micrometers and dial bore gauges, but I don't use one. I pretty much do everything by feel, and it's very, very simple. Here's the intake and exhaust valves. They're looking a lot better.
Yeah, those are the original.
These are the original, so
they were looking a little orange and
yeah,
all sorts of stuff.
They get glass beaded on the face and the back side. Then we polish the stems, and then we regrind them. And then on the intake, once the intake is, once we do the valve job, we'll go back and we're going to put a 30-degree back cut right above the sealing line for that 45 degree. It'll be 30 degrees right back here. I think this goes for most of them, but at least the 4.6 for sure. The exhaust valves are always 1/1000 smaller than the intake valves. That's just kind of a rule of thumb. However, when we're sizing heads, we're going to use the exact valves that are going to go in that head. So not the exact same valve for every single guide, but that batch. Obviously OE stuff might be different from, say, Manley or Ferrea or another company. But this tool is very simple. It's all about feel. Once you kind of get an idea of where you need to be, these are 1/1000th increments, so it is very, very easy to tune. You'll watch, I have a method to the madness here. We'll do 2 here, and then we'll flip the head over, we'll do 2 intakes, and then we'll kind of go over that portion of it, and then I'll size the rest off camera, and we'll go over and start machining some valve seats. So the first one's always the one that takes a little bit of time. So one thing about this tool, it doesn't like to be too tight, but it doesn't like to be too loose either. If it's too loose, it will wobble around and you're gonna hog out the outer portions of the valve guide instead of having a nice smooth bore. So stability is really important. We'll back it off tooth valve and slide her out. So we got a little ways to go here. Now if you'll notice, I typically don't do more than 7 to 10 strokes. That's because the diamond doesn't have any flukes like a reamer would to evacuate the material. So it just kind of chip loads and we just wipe it off with a paper towel. Now the best thing to do, which I'm having my future plans, is to have an actual home tank with fresh coolant coming out and get rid of the oil. But this works for now, and I don't have any time to build anything fancy. Just a little tight, about half a thou tight, I'd say. So we'll go back to where we were at half a thou. All right. I'll clean the guide bore every time. I don't want anything making the valve feel tighter than it already is. Alright, that's what a properly sized exhaust valve should feel like, just like that. Nice and smooth, no hang-ups. Got a little bit of wiggle when you're pulling it out, but that's it. I know what that setting was, so this one, we're just going to use the same setting for all of them. We're obviously going to check along the way when we're cleaning the tool. Just how I want it. Now here's the difference though. This valve is only a thou bigger. And while it does fit in, it is so tight you would never be able to run that like that. So what we have here is about 1.5 thou of clearance on the exhaust. I try to run 1.5 thou or so on the exhaust and 1 thou on the intake. Alright, so this is what a well-sized guide feels like. Obviously you guys watching can't feel it, but you will see I'm going to pull the valve out of probably 1 inch off the seat, and I'm just going to try to wiggle it just a little bit. Just want a little bit of clearance. Now, earlier I said that this valve was 1/1000 smaller on the stem. I'm just put it in there for reference. You can see it ticking back and forth. So that's the difference, just 1/1000 will make in guide clearance. So it's very easy to tell if you've gone too far. Somebody starting out on this tool, honestly, I would probably maybe use a carbide pilot as a reference, something that doesn't have a ton of taper in it, so you can just kind of creep up on it. But it's really, that's all you're doing is creeping up on it. Alright, so we got the head loaded in our seat and guide machine. Some of you have probably seen this style machine before. Some of you probably have not. This is literally nothing more than a glorified drill press. We have a bunch of custom tooling for it. What we used to have on here was an ER32 collet drive, but this one's a little bit better. Either way, it's a hex drive, and it locates the pilot all the way up into the spindle. One thing that makes this machine very easy to operate is it floats. The table floats. There are a couple different versions of this top portion, so the version you would not want to use all the time if you're trying to get anything done in a timely manner would have this style lock on both axes as well. These are airlocked, so literally you just open a valve right here. They're unlocked. You can move the table however you want once you're leveling your leveling the head for the actual valve seat you're about to cut. And then you simply push it in, air pressure pulls back, and the table's locked. So I couldn't imagine doing it with this, but it's an old machine. Has no reason to be replaced right now. You can cut an awesome valve job with it. Another thing is tooling. I'm going to use 4 different seat cutters here. I'm going to use 3 different ones for the intake, and I'm going to use just a single for the exhaust. The exhaust is going to be a 2 angle plus a radius, so a 39-degree top cut. That fits my chamber work pretty well. 45-degree seal cut, which is kind of the industry standard there. And then after that, it's a radius all the way down to the port. Intake's going to be a little bit different. Intake's going to be 39, 45, 60. Then we're going to add an 84, and then I have a radius 94 that just splits that at the port. Everything is pretty much sized off of this tool right here. Take your valve that you're going to want to use, and you're just going to set it up at the very edge of the seat. Make sure it's tight. Just like that. Whatever pilot we're going to use, it's going to be the same diameter as the valve stem here. And we would put our cutter on here and index the 45-degree angle at the very top. I've seen guys try to run oversized valve on not oversized seats. Ford, especially on the 0304 Cobra heads, that valve job should max out the valve seat with a stock valve. So if you have oversized valves, has a less than adequate valve job, and or the 45 is sealing on the chamber and not the seat itself. So just something to keep in mind. We either run stock valves or standard size valves on the stock seats for the GT500. If you want to go oversized, then all the seats get replaced. There's no ifs, ands, or buts. It's not going to fit on the seat. I'm going to take a few minutes, set up my tooling, and then we'll get to cutting some seats. Okay, so now I'm going to get the head level to the spindle. So probably like once a month, we are going to index the spindle to the table, make sure everything's straight. And then anytime you replace guides, you're going to need to cut a valve job. It's just there's no way around that. They're not going to be perfectly straight. And one's not going to be the same as the other, so you have to do this to every single one. Just got to get it in the ball part so we can lock the main part, and then we'll use the air locks after that. So, bubble's never going to be in the middle. This gauge likes to favor one side. There's really no reason to adjust it. You're looking for the same offset on both sides. So, should be close. Just on the inside line there. And I would say that's good from where I'm standing. Alright, so now we're going to machine our first 3 angles. These seats are kind of soft, so they like to chip load. Definitely not my favorite seat to cut. They also don't look really pretty, so I am going to use a little vegetable oil, or vegetable-based cutting oil on this. It seems to work very, very well. We're going to go just till we're blending the top cut just into the chamber. Alright, we got our first few angles, and now I'm going to do the second and third off. This is our 4th angle. And we're just trying to match it. Essentially what we're doing is, the bottom of the 3rd cutter is a very long 60-degree angle. We're coming in with a more aggressive angle and making that angle the same width as the sealing angle, which is approximately 40 thousandths. Now my final will take that and split that angle as well. And now you can see there's just a little bit of a lip of aluminum, but we will blend that by hand. That's going to be the next step, is after valve job, everything gets blended by hand to the bottom cut from the bowl area. Alright, so the next step, I'm going to make sure we got our tool set up right, make sure everything's cutting, nothing came loose. So we're going to lap an intake valve on that seat pocket. Make sure it shows up good on the seat, make sure it shows up good on the valve, everything's concentric. Once we do a second one, we'll vacuum test the port. We typically just do this on the first one, make sure everything's good, and then do the other 8, and then we will lap it while it's still on the machine, in case there's any discrepancy or something needs to get touched up or something like that. Alright, and this is what a properly cut valve job would look like on the valve. I don't know if you guys can see the lap line there.
Yep.
Okay. So the portion that is still shiny, we're gonna run a 30-degree back cut all the way down to where you can see my lap line there. And that'll improve the flow on the intake valve. So this intake valve is not undercut like some of the aftermarket ones, although it is very favorable for an OEM valve. Just for reference, I'll show you an aftermarket valve. I think this is a Manley, yeah. So see, Manley already has their back cut on there. We'll add to that and make that back cut bigger, but you can see right here the stem is undercut, whereas this one is not. So that's just done for a little bit better flow. Just got that little baby lip right here. There's some casting underneath that too, so we're gonna hand blend all of that right to the seat. You can see the top cut right here complements the chamber a little bit better. That's why I decided to use a 39-degree top cut. Most of the cutter blades that you can buy, a lot of them will have a 35-degree top cut, and that's just not steep enough for what I'm trying to do here. So you can also see our second angle, the 45-degree, like I was talking about earlier. It's maxing out the seats. There is no part of the valve that's touching the chamber, and we are maxing the seat out. So you cannot put oversized valves on stock seats, on this head particularly.
So this is your party trick?
This is my party trick. So when a valve bounces like that, that'll show you that the valve seat is very concentric. You could try it on another seat that hasn't been machined, and it's just gonna be dead, like, you know, like that. It's not gonna bounce. So now we're just gonna show you how straight this table is, and if you take your time to level everything, this valve guide has 1.25 thou to 1.5 thou maybe max clearance. We're gonna jump this valve completely out of the chamber and watch it go back and bounce. It might take a couple of times, but it's gonna do it. But anyways, bouncing the valve against the seat will show you that first off, that your table is straight and level, and also that the valve seat is concentric. This is our 39-degree top cut here. Below it is our 45-degree seal cut, and then down here is the radius, gonna go all the way to the port.
All right, so you still got a lot more work ahead of you.
A lot more. Probably another hour or so on this head, give or take. So what you guys saw earlier was just sizing the guides and stuff. I would say for me, 1.5 hours or so to do a 32 valve head, and then probably another 1.5 hour to 1.5 hours to do each 32 valve head, each 16 valve head in the seat and guide machine. So it's a lengthy process. I don't think people realize how much time and effort goes into cylinder head machining when you're changing all these parts. Like I said earlier, I only use bronze guides. I've only ever used bronze guides. I don't think I've ever cut a valve job on a head and sent it out with the stock guides in it. It's just, they're always wore out. These seem to be very, very well if you size them right, and you're helping the thermal properties of the valve. So
yeah, a lot of people skip over head work, and I mean that's what's going to set this engine apart from you know, just doing rods and pistons.
Correct.
You know, it's going to flow really well together.
I mean, if you're just a basic freshen up is good. You know, just valve guides and a valve job, regrind the valves, get the carbon out of the ports. I mean, after 100,000 miles, the valve guides are toasted most of the time. And I continue to see people reuse them, and then the heads normally end up here, or somebody ported around the guides, or they just knocked the guides up for porting and knocked them back down. I wouldn't condone any of that. The best way to do it is put a fresh set of guides in there, size them to the valves you're using, cut a good valve job, and have a head that's gonna last a long time and be very reliable. That's it for tonight. Have some bad weather rolling in, I think.
Yeah.
Next week we're going to we'll do a special on crankshaft balancing and balancing the whole rotating assembly and how all that works, and then we'll also go into cylinder head assembly, you know, blueprinting the head, blueprinting the spring pressure, valve heights, all that good stuff, everything that makes a good combination. So
yeah, and the block should be in soon, and then
block will be back soon.
Final assembly is coming very soon.
I think we're waiting on cams still, but shouldn't be very long.
Heck yeah.
Other than that, everything is here and ready. We're gonna keep moving forward.
Heck yeah. Sounds good, man. So I hope you guys are enjoying all the info that you are getting on various different pieces of the 5.8 liter GT500 build. Make sure you leave a comment down below if you have any questions or anything, comments, leave them down below. Hit the like button, and we will see you guys in the next one. We got a lot of fun stuff coming. A few weeks, something like that. We should be starting the motor up and making some horsepower with it.